All right, so this particular problem here, it says a 2 ohm, a 3 ohm, and a 5 ohm resistor are connected in series to a 60 volt battery. What is the current through each resistor and the voltage drop across each resistor? So if we have 3 resistors connected in series, then this picture right here would work. Again, the way I drew that picture, you can have, it doesn't matter whether you have, I could put all 3 resistors all on top. I could put all 3 there. I could put 2 there and 1 there. As long as I have 3 resistors that are connected in series to the power source. So in this problem, I'm going to have that it's a 60 volt battery, so I'll write that in. And then I'll call this one R1. So R1 is 2 ohms. This one I'll call it R2. It's 3 ohms. And this one is R3, which is 5 ohms. Now, when I ask the questions about them, I probably won't say what's I2 or what's I3. Like I will say what I'll say is, instead of what is the current through resistor 1, I would say what is the current through the 2 ohm resistor, because maybe for whatever reason you don't have them labeled with the same numbers that I do. Right? So if this is the problem, the first thing that we want to do, well, I do want to say that this is V123. So when you're figuring out the voltage on the battery, you're just going to add in whatever's out there. So whether there's a parallel section, whether it's just a series, whatever numbers are being used up here, I like to use the numbers down here. That's what's out there. That's what's out there in getting from here around to there. There's 3 resistors out there. So so I know like a lot of books will, instead of using numbers, they'll say, like, especially when we solve for the equivalent resistance, they'll write it as R subscript EQ. But if this is a combination circuit, there might be more than one thing that we have to combine to calculate an equivalent resistance. So I like to use the numbers. So in this problem, it's very easy to calculate the equivalent resistance in series because it's just equal to just add up the resistors. So if I add up 1, 2, and 3, then you add those all up, they add up to 10. All right, now I know normally I say show me the numbers that you put in, but something that is that easy that you can just read off the picture there, I'll accept that. So the equivalent resistance is R123, and then once we know that, we can figure out the current that leaves the battery. So the current that leaves the battery is going to be I123. So to get that, we're using Ohm's law, so it's going to be V123 divided by R123. The great thing about these problems is the math is very simple. In every one of these calculations, you're either multiplying one number times another by another, or you're taking one number and dividing it by another. So the math shouldn't be a problem. You just want to make sure that you're dividing the right number by the right number, or multiplying the right number by the right number. Bless you. So we're going to get 60 volts, and that's going to be divided by the equivalent resistance, which is 10 ohms. So we get 6 amps. And to 3 significant digits, I would write that 6.00 amps. Right now, since I know that, I now know what I1 is, I2, and I3. Because if that's how much current leaves the power source, the battery, then that's how much current has to go through this resistor. That's how much current has to go through that resistor. And that's how much current has to go through the third resistor. So in series, if I know the total current that leaves the battery, then I also know I1, I2, and I3. They all equal I1, 2, 3. And we just calculated that as 6 amps. Now, in series, if the current leaves the battery, it has to drop 3 times, because when it goes through something that's using the electricity, the voltage is, we're going to have a voltage drop there, we're going to have a voltage drop there, and we're going to have a voltage drop there. So the total voltage on the battery is going to have 3 separate drops as it goes through. So when I add those 3 up, they should add up to 60 volts. So the next thing to solve for is that. So we're going to have V1 is going to be I1 times R1. V2 is going to be I2 times R2. And V3 is going to be I3 times R3. I solve it like I'm doing an assembly because I'm going to solve all 3 at the same time. And so this one is going to be I1 R1, I2 R2, I3 R3, and in all 3 of these, the current is 6 amps. And the resistors, I've got 2 ohms, 3 ohms, and 5 ohms. All right, so adding those all up, the numbers were nice and rounded off, so it should be easy enough to do in your head. 6 times 2 is 12, so we're going to get 12 volts is the voltage drop across the first resistor. 18 volts is the drop across the second one, and 30 volts is the drop across the third one. If we add them up, they do add up to 60 volts, so it does check. Now, the only other question that I could ask you is I could have asked you maybe a power dissipated in one of these resistors. So let's say I wanted to know the power that's dissipated in the 3 ohm resistor. Well, that would be P2 equals V2 times I2. So that would be V2 is 18 volts. Now I'm going to write that as 18 joules per coulomb because that's what a volt is. You don't have to do it, but I like to see that I get the correct unit. And then my I2 is 6 amps, and an amp is the same thing as a coulomb per second. So the coulombs will cancel the coulombs, and I will get joules per second, and a joule per second is a watt. So that gives me the answer for that. So 18 times 6 is going to be 108. So 108 watts. So that would be the answer for if I ask you to solve for power. And I told you there'll be, I'll give you a problem like this, but there'll be 4 questions. So maybe I'll say the first question might be, what is the equivalent resistance of this circuit? And if that was the case, then the first question would be, that's the equivalent resistance of the whole circuit. Then I might say, what is the current through the 3 ohm resistor? Well, the 3 ohm resistor is this one, which I've labeled as R2. So the current through the 3 ohm resistor would be 6 amps. That would be maybe the second question, the part B question. And then I might say, well, what's the voltage drop across the 5 ohm resistor? Well, I labeled that R3, so the voltage drop across the 5 ohm resistor would be V3, which is 30 volts. So there's 3 questions, and then maybe the 4th question would be a power question. So maybe I would ask, what is the power dissipated in the 3 ohm resistor? And the answer to that would be that. And there's 4 questions. Now, when you're doing this on the test, you can make life a little bit easier for me by where those questions are. Right next to the question, put your answer for part A, put your answer there, and then B, C, and then D. Put the answer right there so I don't have to hunt for it in your work. I mean, if your work is nice and neat like this, then it's easy enough to find. But if it's not, it's a little bit tougher to find.